So let's look at a couple more water flow questions. So what we have here is water is kept cool in a cylindrical container of diameter 28. There's enough room on to put the radius there, 14, and height 30, and both in centimeters. The water is poured into small cylindrical cups, cylinders again, each of diameter 6 and height 7. So we'll go cylinder 1 and cylinder 2. I've got a radius of 14 and a height of 30. And cylinder 2, I have a radius of, be careful now, they give us the diameter here 6, so I have a radius of 3 and a height of 7. When the cooler is full, how many cupfuls of water does it contain? When the cooler is full, how many cupfuls of water? Right, well, we can get the volume of the cylinder of number 1. The volume of 1 is pi r squared h. And that's equal to, we leave it in pi here, pi by 14 squared by 30, which is 5880 cm cubed. The small one, volume 2, is equal to pi by 3 squared by 7, and 7 nines is 63. So 63 pi. Left out my pi up here, which you all noticed, of course. So if I divide 5880 pi, if you want to put it in, they could cancel, by 63 pi, we're going to get 93.33. We asked for full cups. How many cupfuls? Well, probably 93 cups with a little bit of wastage, obviously. So 93.33 exactly. Okay, water flows through a cylindrical pipe at a rate of 10 centimeters per second. The diameter of the pipe is 7. Okay, let's have a look at the diagram here. We've got a pipe. What a brilliant diagram. Right, so we have a radius of a pipe. We have the length of the pipe. The diameter of the pipe is 7, so the radius is 3.5. And it's 10 centimeters long, and this is what happens in 1 second. This is, so if you imagine that this is like the end of the pipe, how much would come out in 10 seconds? Sorry, how much would come out in 1 second? And it's 10 centimeters long worth of this pipe. So in 1 second, what can we say? The volume that moves in 1 second is equal to pi r squared h. They don't tell us anything about pi. We have a 7 and a 3.5 in there, so I'll take 22 over 7 by the radius squared, which is 3.5 by 3.5 by the height, which is 10. And 22 over 7 by 3.5 is 22 by 1 over 2, which is 11. So 10 by 3.5, 35, 35. 35 here by 11 here is 385. So that's the volume that will go through in 1 second. And we asked about a minute here. We're asking 1 minute. So if I multiply this by 60, that's going to give me, it's going to be 23,100, and that'll be in centimeters cubed per minute. That's what's going to go through this pipe, or we might let it cut off what's going to come out the pipe at a certain point. Now water is poured into this empty rectangular tank here, 70 by 55 by 20. Okay, so what's the volume of that tank? Let's have a look at the volume. Well, we're asked for the water depth. Actually, that's part A, isn't it? Where we haven't got, we just got the flow so far. Look here, what is the water, the depth of the water after 1 minute? Well, we don't know then this H here. So what we don't know is this 70 part. It's definitely going to be 55 by 20. It has to be 55 by 20. So we imagine that 55 by 20 by H is the height, we're going to get 550, 1100, sorry, 1100 H is equal to the volume of water, and this is after 1 minute. We just said that there's 23,100 is the volume inside the tank, so H is equal to 23,100 divided by 1,100. That gives me exactly 21 centimeters. So it'll be 21 centimeters high after 1 minute. And then to the nearest second, so we're going back to seconds here. How long will it take to fill an empty tank? Okay, what's the volume of an empty tank? 70 by 1100 is equal to the volume of the tank. So 70 1100s is going to be 770,000, isn't it? 70 by 1,000, 70,000. 77,000. And if we divide 77,000 by the 23,100, we're going to get 3. It's actually recurring. So that's 3 minutes and a third of a minute. If you understand me, which is 3 minutes 20 seconds. 180 seconds plus 20 seconds is equal to 200 seconds for this pipe to fill an empty tank.